Hello, this is Doug Walton, and this video concerns my final project for CSCI E63 Big Data Analytics at the Harvard University Extension School. The topic of this demo and this presentation is the U.S. Federal Election Commission data and how that can be viewed in network diagrams or graphs so that we can see the relationships of donors and committees and candidates. I became interested in this as part of a much bigger interest in how citizens can use government data to foster greater accountability of government and also to create a more evidence-based involvement in public discourse. This sentiment was recently also expressed by Steve Ballmer, former CEO of Microsoft, when he opened his new website usfacts.org, and he said, I want to have the same kind of data as a citizen to assess this that I would have had as CEO of Microsoft for Microsoft's operation. Now, in looking at what to do for this project, I did find quite a few different data sources. There's data.gov, which is called the home of the US government's open data. There's the longstanding EDGAR database, which is the data from the Securities and Exchange Commission. There's the Steve Ballmer's website, which is usfacts.org, and also the General Social Survey, which has been going on for a number of years, created by the University of Chicago. And it also tries to get a sense of uh, characteristics of people in American society. All these databases are great. They have a lot of great information out there, but they have many diverse tables. Tables are made for different purposes, and they're presented in media that is not always amenable to drilling down. So that was the challenge here as a big data challenge, is to say, well, what can we do with all of these different tables and different ways of presenting the data? Because often the insights are in how the data is combined or being able to explore the data, not just have it presented to you in the format that someone else thought was important. So what I did was I chose from data.gov, one of their web services, which is called the Open FEC API, so Open Federal Elections Commission API. And this API has a number of endpoints in it. These endpoints are specified as kind of a folder-looking name, like candidates, as you can see here. And they also have a number of available operations on the endpoint. And each operation on the endpoint has certain variables, and those variables can be assembled into a request URL string, and that can be used to query the endpoint. Successful query of the endpoint produces a JSON file of different types depending on what variables are used by the operation. My goal was to take these JSON files and merge them or integrate them into a graph database so that the network could be explored and we could perhaps get visualizations or see patterns of information more easily to understand the flow of money in donations. So I chose Neo4j. Neo4j is arguably the most popular graph database around. It is organized differently than SQL, so it is organized by nodes or elements and relationships or edges rather than tables. So you can see on this slide at the bottom, there's kind of a representation of it. There's nodes and edges, and the edges are labeled as to what their function is and what their direction is. So this permits visually finding patterns that might otherwise be hard to spot. Neo4j has three different editions: the Community, Government, and Enterprise edition. So this demo uses the free Community edition. And it will also rely on Neo4j's Cypher query language, which enables us to model in kind of an ASCII art format how to match different patterns in the database, such as whether node A likes node B, as shown in the example below. The architecture for my demo involves accessing three of the OpenFEC endpoints. These are receipts, committees, and candidates. They use a single API key and a single kind of API interface framework that's provided by data.gov within their own kind of unique set of endpoints from other web services offered by data.gov. I access these endpoints using a three client-side Python 3 scripts. This is FEC donors py, FEC committees py, and FEC candidates py. And these scripts query the data, query the endpoint, and successively build the graph in Neo4j. So each one builds on the next. It starts with starting with donors.py. So the idea here is that the scripts have a certain order. Generally, they run in a way to. The concept here, or the metaphor this is based on, is that the donor was the primary person. There could have started with candidates and worked backwards, but I thought following the money forward would be the most interesting way. And so the first script gathers the donors and creates the donor attributes, and then creates the committee relationship. And then the next script, the committee relationship created in FEC donors.py is just a shell with the committee ID, and then the next script goes and finds and enriches the committee data with other information like its name and the candidate that it supports, and its type of committee and things like that. And then similarly, that one creates a candidate or shell and the candidate or node, and with just the candidate ID with a relationship to it. And then FEC candidates.py comes and fills out the candidate data so we know them by name and party, which is, of course, much more interesting. So what we get from this then is a pretty large graph. I used a pool of about 11,590 nodes, or it was actually 15,000 records, but because of duplicates being filtered out, it came out to about nearly just under 12,000. And of course, that's pretty overwhelming to take a look at. So we can pose different questions now to this visualization and kind of see, what some of this means. As you can see from the one here, I mean, it is interesting. Why are they grouped in these different patterns? But we can drill down into it. So the first one that I decided to do was just to see what candidates were in the database, since it was a sample of all possible candidates who was in there. And one surprise did arise, and that was that former US President Ronald Reagan was in there, which of course stimulated my curiosity, and I decided to look into that. And the way to do that in this framework is to click on the node and get some information, which you can see in the lower part of this slide, where it's highlighted that we needed to have the candidate ID to make a more unique and positive selection to see what was going on here with Ronald Reagan's still existing campaign. So so rewrote the Cypher query on that to, as you can see at the top, the Cypher query queries for a candidate, but it now has included the attribute of the candidate ID, Ronald Reagan's candidate ID, and then looks for what nodes support them. And of course, we did find a committee marked in green, and several donors that had also contributed. And this is in the first part of 2017. It turns out the committee name is the Republican Party of Louisiana, which is probably not hugely surprising, but it possibly indicates that they support many candidates and haven't bothered to update Ronald Reagan's name in the database, was my initial guess, which we don't know without going into some other records not available at this point. Another way to look at this then is how many candidates might have more than one committee. So you can see the Cypher code here to select the candidates and the committees that they're connected to, and then we can see the kind of general layout of them, and that it doesn't really look like there's any candidates with more than one committee, which in this database I have seen in other trial runs that there were some with multiple committees. Another way to look at it is what about donors to more than one committee? So how politically active are people? So this code here, or this Cypher query here, was used to select out committee or relationships where there was a donor. As you can see from the ASCII art version of it, a committee donated to by a donor who also donated to a second committee where the committee IDs were not the same. So it's a little hard because there's a lot of lines in there to see them. So we can take a closer look, and we can see just one particular one here happened to be a donor named James McCarthy, and we can see that he donates 2 times, once to the Visa Committee and once to the International Association of Firefighters. And as we have at the bottom here from Neo4j, the kind of rose view, we can see the committee he donated to, the relationship, his information, and of course, it's not surprising that since his occupation is firefighter and EMS, that he donated to the International Association of Firefighters and wanting to advance their causes. And then for some reason, he donated to Visa as well. So that's one way to drill down on the data and take a look at how we, by looking at the graph and kind of seeing different patterns, we can drill down into look at what's going on there. At this point, asking a few further questions. And then another way to look at it would be to say, well, who are the big donors? Let's weed out all those thousands of nodes. And one note, which I was going to mention, there is a limitation here just from my settings of even though there's 12,000 nodes in the database, only shows about maximum of 300 nodes at a time. So even though some of the so it kind of limits the number that we even saw on some of the previous screens. So in this query, we we were looking for people who donated over 2,000. So the query was amended to show that at least the relationship 1 amount was over 2,000, and then return those there. And you can see that this cut down the number of donors that we collected from the query quite a bit. And many of those donors, big donors, appear to donate to multiple committees, multiple times to multiple committees, as we can see from the lines where the donors are red and the committees are green. And the bottom inset row view gives just one line, or one line for one, 2 lines for one person, showing kind of how Mr. George Bennett here, a business executive, donated to the Friends of Max Baucus and also to Shaheen for Senate in 2013, this one. So in summary, there's a lot of different things we could do there. Exploring the graph database is fun and insightful. It leads to a lot more questions. The data is very disparate out there in the world, and so this is an approach that can handle that variation. We can have, different sets of attributes for different people. It doesn't require the rigidity of a SQL database. Some of the cons, there are a limit to the number of nodes and relationships that you can process in one view, so you need to kind of think creatively about how to extract patterns and relationships that might be needed. And there would be probably a need to take this further and also deal with more descriptive statistics, tables, and sorting, as well as the network view. I learned a bunch of things from this too that are also of some interest. That it's just because the data is there on a government website doesn't mean it's accurate. There were some indications of mistakes and outdated material. That many nodes and does run a little slow on a PC, and probably would need to upgrade how it was handled or what kind of machines it was run on in the future. We would need maybe a more flexible way of configuring the searches so that the database could grow in different directions. I had built it by selecting a set of donors and then building out the committees and candidates for those donors. But as you think up more questions to explore, it may be useful to go into other years, or other regions, or collect other sets of data. It will be too much to collect it all, but may be nice to be able to collect data on the fly and update the graph. And then also when dealing with disparate sources, I had built them from donors forward, but it may have been better to work backwards from candidate or committee. That was recommended by the FEC website, but it did provide some interesting insights either way. So that pretty much concludes my presentation. I hope you found it interesting. Thank you very much.